To the last day of the third session. We're going to be hearing this morning, the sort of theme for this morning is taking these tools, a lot of which need to be developed and put into production at a large scale, right? But we've been focusing at small problems on our laptops this week. So this morning we're going to hear about what is the actual sort of way to put those problems right into scale. So going to the big machines that we've talked about, but we haven't had a chance to use much. And so much like in session 2, we heard a lot from Ashish about all of the sort of great things that are now happening in industry with machine learning. Yusra is going to tell us a bit about the great things that are now happening in terms of cutting edge industry development of databases. So without further ado.
Thanks, Adam. We talked on Wednesday about parallel databases and new systems based on MapReduce, and I promised a Amazon Web Services based demo on Spark. So this talk today is going to be based around that. There's a couple steps in the process that take some time, so I'm going to be switching back and forth between the demo and some slides while we're waiting for Amazon Web Services to boot up the cluster and whatnot. So first, we're going to talk a little bit about cloud computing, and then we're going to go through a Spark demo and then see what the trends are in industry these days. Where we left off on Wednesday, we were talking about how you have to think about your project requirements when deciding how to store your data. If it's small and you don't need to share with a lot of people and the project will be relatively short-lived, you can just use your laptop, or you could use your university managed hardware that you purchased with a grant, or you can apply for some time on one of the national scale clusters. But another option you could have would be to use cloud computing. On the far extreme side, you would have a project like LSST, where you would buy your own cluster because you need it to be configured for your specifications. Cloud computing comes in. There's a number of services out there. Amazon Web Services, in my circles, is by far the most popular. You could also use Google Cloud. These are the main multi-purpose services. There are also smaller, specialized web services. For example, the University of Washington Computer Science Department offers a cloud service for parallel relational databases called Myria, and it's designed specifically for scientists. I've never used it, but I know that different groups on campus at UW do. Another example of a very specialized cloud service would be Databricks. Databricks is the company that spun off of Spark to support private sector business. The business model for supporting open source code is a little interesting. So you can't charge for the software. So these companies like Continuum Analytics, which you guys use in the form of Anaconda, they will support private sector use or enterprise use of these open source codes, and they have real employees that need real paychecks. And what they'll do is they'll consult for companies and make sure that the software is running and configured for them. So Databricks is one of these companies specifically for Spark, and I think they even got a lot of the same people, right? But they also provide a cloud service where you can go and run Spark on their hardware. I haven't tried it. I suspect it would be a little on the expensive side. But today we're going to be using the most common, Amazon Web Services. How many of you guys have used it before? You, as grad students, you can sign up for free credits. I think you get $100 just for being a student. And the rationale is if you use it for free now, later when you're faculty and have your own lab or you are working in the private sector, you are more likely to adopt Amazon Web Services, I suspect. So let's fire up a cluster. So you go to console. Let me know if at any point you can't see what I'm doing. So if you go to console.aws.amazon.com, you will see they have a variety of services that you can choose from.
Yusra, can I pause you for a
Yeah.
second? Do you, I don't know the answer, do you think people should try to quickly sign up for an account and follow along, or just watch what you're doing?
I think it would be easiest to watch.
That based on my experience, I would guess the same. So,
If
yeah. I see a
you-
few people trying to fire up accounts right now. Maybe hold off on that and just watch what Yusra's doing.
I think you can still look at the web page and what's available without an account.
Also, about a week ago, Amazon had a new security policy. It heard us in a workshop. When more than 5 people sign up from the same IP address, they added delay for those people to launch instances because they consider that as a fraud activity. It happened to us at our workshop for the Granny Hall. We found out the hard way.
Good to know.
So maybe don't sign up for it.
Space yourself for 5 minutes.
Yeah. Or if you have a VPN, go through your home institution.
Yes, that would help.
Yeah. Okay, the most commonly used services is the Elastic Compute Cloud. These are just, if you just need a server that you can SSH into and do whatever you want with, have root access, you would instantiate an EC2 instance. We call them an instance. If you need to store some data, the storage that is most available to the EC2 instances is S3. Let's just look there for a second. When you click on this, you'll see a couple buckets that I have created in the past. It'll tell you what data center your data is physically being stored at. And I'll show you the files that we will be working with in the demo. In one of the examples on Wednesday's talk, I mentioned this workflow I had where I had a small table that fit in memory. It was around 2,000 rows, and a larger table, and that was the exposure info that had the calibration for every coad that we had generated. So this had the photometric 0 points. And then I had another table which had 23 million lines, and every line was an astronomical source with a flux measurement in counts. And I needed to join them to pull in the 0 points so I can compute a magnitude on each one. So this is that same data set. And you'll see the small table here and the large table here. The large table compressed is 11 gigs. So this, with my 16 gigs of memory on my laptop, would definitely not fit once it's uncompressed. We also, we talked on Wednesday about the Hadoop distributed file system, and we also mentioned how the default redundancy is 3 times, and somebody asked about that and mentioned it sounded a little bit high, and I'm guessing it sounded high because RAIDs, for example, usually use double, 2 times redundancy. So while 3 is the default, that is just a default, and you can reconfigure that to have lower redundancy if you want to. You can also do something similar with your S3 data, and I specified reduced redundancy here because I had backups on my home machine and I didn't need them to make this completely fault tolerant. So if you were to instantiate an EC2 instance server right now, these data files would be available. Okay. We are going to use the Elastic MapReduce service down here, and the tooltip says that this is a managed Hadoop framework. What this does is it installs all the necessary software for you, so that you don't need to worry about that. Yeah, you'll see all the clusters that I made while while double checking that this all works. And you go to create cluster. And you can give it a name. And then you have a few options of what software you want to be automatically installed on it. We talked about Hadoop, HBase, the column store based on Hadoop. We didn't talk about Presto. Presto is a Facebook product, which also supports distributed queries, SQL on MapReduce. But what we're going to work with today is Spark. And now you can choose what hardware you want. This is always changing. What's available is always changing, and so every time I do this, I have to look up what they are. If you don't know what you want or you don't want to think about it, I usually just go for the general purpose, cheapest one available, especially for a demo. Okay. You can check the prices. So each server is going to cost 12 cents per hour, and the Elastic MapReduce service is going to add 3 cents per hour onto this, and this is pretty minuscule, but this is for the installing the software and adding the extra glue. But I do, if you're doing jobs like this, I recommend using this because it makes it a lot simpler. Okay, let's do one master node and then 3 worker nodes. You also need to create a key pair for security. And so I had already done this, but you would just follow the instructions for creating a pair. And now every time I log into this instance, I would use the private key that's on my machine. Okay, let's create this cluster. Okay, so it's starting up, provisioning, and this could take anywhere between 3 minutes or 10 minutes. So I'm going to go back to the slides at this moment. Any questions on what just happened? Yeah?
So it's starting up right now. Is this charging you for the time, or is it only going to charge you when you actually put something on it and have it like
it is starting to charge me right now,
Okay.
even though there's no server available and I can't even log in. So they don't, from their perspective, it's like, it doesn't, and this is important when using Amazon Web Services, they don't care whether you use it or not. They only care whether it is provisioned or not. So because this server is no longer available to anybody else to use, you're being charged for it. Kind of like utilities in your house. If you were to leave the heating on and go for vacation, the energy company doesn't care if you didn't use the heat, they're still going to charge you for it. I'm going to jump around a little bit. Okay, how about, so since we're doing a Spark demo, what is Spark? You'll remember on Wednesday we talked about how Spark is based on these resilient distributed data sets. These are in-memory tables that exist on each of your nodes, and it facilitates computation on these in-memory tables. So some differences between Hadoop and Spark is that Hadoop is just computation on disk, and you execute programs in batches. And you can only use, if you're using core Hadoop, you can only use Java. And that was true until the SQL layers on top, like Hive and Pig, came out. This was a non-starter for astronomers. Spark, on the other hand, you can use it in batch mode, but you can also use it in interactive mode, which you'll see us do during the demo. And there are a variety of language layers on top of it. For example, Python, R, and Scala. And
I think Hadoop, you can also use other language for the script. The main computational call is written by Java.
right, there's these new services that run on top of Hadoop that convert your language into calls, Java calls to Hadoop. So there are services now that go on top of Hadoop, which make them more usable. We talked about this on Wednesday, where you have column stores, you've got things that look like indexes, you have things that look like transactions now, and you have the actual SQL language on top of Hadoop. So people started paying attention to this for the flexibility, and also in 2014 it won the Daytona Gray sorting contest. This is a big data benchmark to see how fast you can sort 100 terabytes of data. Since then, they're no longer the winner. I think a group from Alibaba is the current winner. But this was very compelling. Let's see. Okay, let's see how our cluster is doing. Okay, not ready yet.
Can you introduce a little bit about Zeppelin?
About what?
The Zeppelin?
Oh, Zeppelin? Yeah, we're going to look at Zeppelin. I mean, we're going to use Zeppelin. Okay, let's let's talk about big data tools in general. Okay, so Gartner is a research firm that provides industry research for investors and the like on emerging technologies, and they developed something called the Gartner type cycle, where they've noticed this pattern that emerging technologies take. This is the one from 2012. The idea is that you have this initial technology trigger where there will be some new advancement or discovery, and everyone will get super excited and invest money, time, until you reach this peak of inflated expectations where everyone thinks that this is going to solve all the world's problems and everything's going to be great. And then people start trying to develop it and use it, and you fall into this trough of disillusionment when you realize that, oh, this isn't actually going to solve all our problems. But slowly and surely, people put in more and more work and find more and more real business applications, and eventually we reach this plateau of productivity. So in 2012, this idea of big data is climbing the peak of inflated expectations. You have cloud computing falling into the trough of disillusionment, and predictive analytics finally reaching the plateau of productivity. So predictive, I'm not going to go. Okay, a couple of years later, you see big data falling down into the trough of disillusionments. Hybrid cloud computing really low. And then in 2016, it disappears. They disappear completely. And the analyst who puts these together was asked why this was, and she says, well, what's happening is that big data has moved over the peak of inflated expectations and has become prevalent in our lives across many hype cycles. She doesn't consider it to be an emerging technology anymore. So how I interpret this as her saying, well, it's kind of obvious now, it wasn't really a thing. It's kind of like saying computers are going to be an important part of technology for everybody. So it's just kind of a non-statement.
Cloud computing is not the same as big data, right?
Right.
But cloud computing still disappeared.
Cloud computing did disappear.
Just become so productive so fast. It's gone off the light.
Yeah, I don't know what happened to cloud computing. Oh yeah, Eric will tell you what smart dust is. Okay, and while we're waiting, I would like to talk about databases in industry in general, and that this fun MapReduce stuff that we're talking about is not a drop-in replacement for existing tools. It's not a drop-in replacement for existing tools in industry. It's not a drop-in replacement for existing tools for science. It is simply different. And if you need it, you would know. It's not a drop-in replacement for high-performance cluster computing. It's also not a drop-in replacement for databases. We didn't explicitly talk about this the other day, but there's two types of database uses. There's transactional databases, and then there's analytic databases. Transactional, and you'll sometimes see this written as online transactional processing or online analytic processing. Those are two types of databases. Transactional databases are, for example, the the ATM example that Adam gave, where you have an actual transaction, you have a lot of updates of single rows, you're buying plane tickets, and as soon as you buy that plane ticket, that row in that database needs to update and let the system know that that seat's no longer available. Banking, orders, accounts receivable, accounts payable. Analytic databases, on the other hand, are for analyzing how your business is doing to figure out what you could be improving on, what's going on. It's for visibility into how your business is going. You'll hear words like data warehouses, which data warehouses and business intelligence. This is the process of taking data, extracting data from your transactional databases and then summarizing it into these databases that the analysts then use to query for history. Of these two options, which type of database do you guys work with? Like which one sounds more similar to your workflow? Lots of inserts and updates, or lots of selects and analysis. Analytics, definitely. And the tools for these types of databases are a little bit are different, and the requirements are different as well. So what companies are doing is if they're trying these NoSQL systems, it is in addition to their transactional databases and to augment their data warehousing needs. So we talked about this, the other thing on Wednesday as well. There's regular relational database systems, you get queries back super fast. But with these NoSQL systems, there's some inherent overhead in them. And they're great for big jobs, but if you want to find the needle in the haystack, this is going to take a while. Now, something else we didn't talk about on Wednesday is the CAP theorem, which says that if you partition your data, you have to choose between availability and consistency. This is related to ACID, which Tomasz mentioned in session 1 and Adam reviewed on Monday, where databases are great at atomicity, consistency, durability, isolation. So an example to show this is, say you use a distributed system for something that needs to be transactional, like buying a seat on an airplane. And you have two people. Amazon, they not only distribute partitions of data within a single data center, they even partition them across data centers across the world. Say you're using one of these systems and someone across in the US wants to buy a seat on a plane, and someone in France wants to buy a seat on this flight, and it's the last seats on this flight. These NoSQL databases, they don't offer consistency. They offer something they call eventual consistency, where the updates are logged and then eventually reconciled. But when these two people both try to buy this ticket, Amazon or whoever is managing this database has a choice. Do you tell them, and say there's some kind of cut in the network between these two data centers. Do you tell them that, sorry, this website's not available? Or do you take the request to buy a ticket anyway?
I think you're using the wrong example, because airlines will just do the same.
The what?
Airlines will just have a book, so.
Right.
They will also
Yeah.
say like tickets pending.
Bad example. So what they should do is not sell the same seed twice. But what my point is it totally depends on the needs of your business, the problem. I haven't confirmed this with Amazon employees, but my understanding is that with what Amazon does is their ordering system uses a transactional database, but the shopping cart system and the displays of what the products are and the reviews and all of that stuff is in a NoSQL database, because that stuff they deemed less. It's more important that you're able to shop and they don't want people to be getting error messages saying, oh, you can't look at the pictures for this product or reviews for this product. So it totally depends on your use case. Let's see how this is going. Something you might have to do is allow incoming connections from your IP. What I was doing there was just allowing incoming traffic from my IP. Let's go back. Let's see if I can SSH into this machine now. Yes. So I don't know if you can see, but I am logged into this machine as username Hadoop. Okay, when I was trying this yesterday, I did not have to do this. Sorry, I don't know email. They give you instructions for creating an SSH tunnel and using a proxy. But when I was trying this earlier, I found that I didn't actually need to do that. So I had figured that they were just old instructions. What I might do is use the cluster that I had already created. Okay. This is a cluster I made a couple days ago. It is much smaller. Sorry, not much smaller. It's got one master, 2 cores, and the web connection is functioning on this one. So as you can see, sometimes there are difficulties in getting the connection working and the security, getting around all the security requirements. This is the demo that comes with this service. So this Amazon, this Elastic MapReduce package that we picked came with Spark and something that is called Zeppelin, which is like IPython notebooks, except it supports a handful of different languages. And this is what you can use to run your jobs. This language that this example is using is called Scala. It's based on Java, but it's fairly similar to Python and is popular for data analysis. What this example is doing is it's reading in this file of bank data from S3. It's not actually going through S3, it's going through the web, and I guess that's so because people would be trying this demo from data centers all over the world, and you're not guaranteed to have this example data set be in the same data center as the person trying this demo. This is just a CSV file, and they parse it into fields: age, job, marital status, education, balance. And then they parse, and we're going to look at this in more detail in the simple demo in a second. But what they do is they split each row and then load each element in each row into these fields. And then register this whole object as a temporary table they're calling bank. So we're going to run this. This is, sorry, not Python. Okay, and this worked fine. At the beginning of each paragraph, as they call it, you can define what language you're going to use, and you do this by this %sign language name. And now you can write SQL to query this temporary table bank. They're doing select age, count of the number of rows from bank where age is less than 30, order group by age, order by age. We scroll down and you see you have the counts of everybody less than 30. Another capability that they're demoing is the ability to put in these input boxes. So what this is saying is count group by age, provide the count, but make the cutoff age an input box with default 30. So here, and I don't know why it defaulted to 35 when it specified 30. But here you say that they go up to...
Isn't 35 what was entered in the box?
Oh yeah, okay. But I don't know how this is affecting that. But I can change this now to 25, rerun it, and they only go up to 25. And the last one shows you how to make a drop-down box based on the people's marital status. I'm going to rerun this. It's the same, you can see it's the same query, but you can see the answers for single people or divorced people or married people. Okay.
Looks like you can make plots as well.
You can make plots as well. This is the same data set. It's the count by age. I would also like to give a disclaimer, which is that everything, 90% of what we've covered in this week-long workshop are things that we use in our everyday research. We unit test our code, we profile our code, we parallelize our code, we write documentation, we use databases. This is not part of my workflow. I don't use Spark for research. I have found that for most things that I do, it takes longer and is more difficult to do whatever job I needed to do. So this demo is really kind of just for fun to see what this is capable of, and to keep an eye out in the future for ways that this will become easier. As more and more people in the community build on this, I think this has potential to become more and more powerful. Okay, what I'm going to do now is import a notebook. I gave them all the same name, so I hope I picked the right one. well, let's just go through this example. We're now using PySpark, so we can write our code in Python. And I'm just creating an array of integers, 1 through 1001. And then using this function parallelize that will turn this array into a Spark data resilient distributed data set, or RDD. These are the basis. This is the main object that your data is held in Spark. You might be wondering what this SC thing is. It is a PySpark Spark context. If you were not doing this if you were using Spark but not in the Zeppelin notebook, what you would do is say import from PySpark, import Spark context. And then that would be the class, the module that would give you all the functionality. But that's done automatically here, and now SC is a PySpark Spark context. So for the first example, let's just make a count. I'm going to load this and count up how many records are in here. 1,000. The most common method to use on an RDD is called map, and this works just like you would expect. You provided a function that you're now going to apply to each row in your RDD. You can either define your function or just provide it as a Lambda function. According to the LSST code standards, we are not allowed to write any Lambda functions in any of the software because they are deemed unreadable. I don't know what best practices the other instructors feel are. I find them for writing map functions or functions to use in a map method. I find Lambda functions extremely useful, and I use them when I'm mapping functions to pandas data frames all the time, but some people don't like them. One thing to know about Spark is that it uses lazy evaluation. It doesn't actually compute anything until you request data from it. So if I comment those out, it's not going to do anything. I have to ask for something. The method for requesting all the data back is called collect. But presumably you'll be using this on data sets that don't fit in memory, so you should use collect with caution. Some options for inspecting the data include take, which will give you the top 10 rows, or top, which will do the same thing. You can also, it also has a filter method. So now we're going to apply a function that returns true or false in order to filter the data set. This particular function should return true if the number is even and false if the number is odd. exactly half the rows got filtered out. So now your filtered RDD only includes the even rows. In addition to map, it comes with a reduce. Just wanted to see if that worked. This works also like you would expect, except you have to provide a function that commutes and is associative, or else you're going to get nonsensical results, because this is going to reduce each partition of your data and then combine those and reduce the reduced partitions. So what this is going to do is add all the elements in your filtered RDD. This is going to do the same exact thing. Remember, summing is okay for this. This is just to demonstrate. We're going to use a non-commuting function just to demonstrate how this gives you wrong answers, completely non-sequitur answers. So these, if I run this, these two lines give you the same answer, but these two lines don't. What this is doing is it's repartitioning your RDD, and so the order of operations is a little bit different. If your data set is too big, you can sample from it. In this example, we have a RDD that is just a list of words, and I want to add the letter S to the end of every word. There's two different methods you could use for this: map and flat map. The difference is that flat map will flatten the results of the tuples that you have just transformed it to. If your function produces tuples, it will flatten those out. And final note is difference between group by and reduce by key. We have 4 key value pairs. A and then a number, and then B and a number. And what we want to do is sum up all the values that are associated with a key A or B. What group by key will do is take all the results from each of your partitions and then send them back to the master node. So you can do something with them like sort them. And this, you would be able to compute a median on these, for example, because you have all the data available now. However, if you don't need the full sets and you just need to perform some commuting operation on it, like summing it up, you don't want to use group by key. You want to use reduce by key. And this, Nick, this was the kind of the example, what you were saying about the word count MapReduce example we were showing, that it doesn't make sense to send every single data value when you could aggregate them ahead of time. So if you could do reduce by key, this will be way more efficient. And the last thing I will show you is, and I know I'm out of time, but you can load in large data files from S3. This one I will run because it should happen fairly quickly. (2,700 rows from this exposure file that I have. But the fun, powerful thing you can do now is read in really large files. This one, for example, has 23 million rows, and it was able to copy this over from S3 and count it up in 8 minutes. I suspect most of that time was spent copying it over from S3. But then, now that they're in memory, you can join them, count them, and perform all these operations on them. Okay, so that completes the demo. All this is open. I know we have to move on to the next talk, but are there any questions on all this? Yeah.
When should we think about moving to something like Scala versus just doing it all in Python or SQL?
I would not recommend moving to Scala. Never. The reason you would is if you went to a company that used it and you wanted to share code with all your coworkers. There's some definite benefits to using code that people in your community use because you can share it and you can get help. The tools are also evolving to have a wider variety of tools or languages.
What's the performance hit in using something like this where, as far as I understand, it translates the languages between each other? Because surely it can't be running all of them at the same time, so it must be like PySpark translates Python to Java, doesn't it?
It does.
So how much slower, if at all, is that?
There is a overhead involved. I don't think most of the overhead is in the language translation, but other components as well. It's part of it though.
And does it actually translate the syntax, or does it execute Python in Jython or whatever the Python interpreter in Java is?
I don't know. You'll notice simple stuff that we did took longer than it would on a notebook, in your laptop. Sorry, Eric.
So I thought, I could be wrong, but I thought it runs each of the languages independently as kernels and somehow squishes them together when called for. I could be wrong.
All right, any further questions? All right, let's thank Yusra.